Hi guys, welcome to my mathematics tutorial. And my name is Peter C. Double Jr., mathematics instructor at the University of Liberia. And in this video, we're going to be looking at finding the derivative of trigonometric functions using the first principle or the definition of derivatives. So to do that, we first identify f of x and f of x plus h. So f of x is already given to be secant of x. So remember, we can just rewrite this secant of x as 1 over cos of x. So since this is our f of x is equal to 1 over cos. The next thing we need to find is f of x plus h. So that is just like changing this x. You want to change this x now to x plus h. So the same thing you did on this side by changing x to x plus h, you must do the same thing on this side by changing x to x plus h. So now we go to the problem. F prime of x is just equal to the limit of f of x plus h minus f of x, all divided by h, as h is approaching 0. So you have the limit. Now, f of x plus h now is this expression, which is 1 over cos of x plus h, minus f of x is just 1 all over cos of x, divided by h, as h now is approaching 0. So f prime of x, we take the numerator expression, we simplify it, the limit. So we find the LCD, which is just the product of the two denominators, cos of x times cos of x plus h. So cos of x plus h into this one is just cos of x. You multiply it by 1, you will have cos of x. And cos of x goes into this, cos of x will cancel, you'll be left with cos of x plus h times this one. So it's cos of x plus h times 1, which is the same thing. So now we say divide, we're going to use the division sign now, divided by h, as h is approaching 0. So we can expand this numerator. F prime of x is equal to the limit of cos of x minus. So we expand it. Cosine of a sum, cos of x, cos of h, minus sine of x and sine of h. That's the expression. All divided by cos of x plus h, as h approaches 0. So the division sign, we can change it to multiplication and reciprocate this one, which is 1 over h. Now what do we do next? We multiply this negative. So f prime of x equals to the limit of cos of x minus cos of x, cos of h, negative is positive, sine of x, sine of h, divided by, so multiply this by this one, we have h cos of x and cos of x plus h, as h now is approaching 0. So like we did in the previous problem, our target here now is to, we can group terms that have common factor. So this first term and the second term, they have common factor cos of x. So we can group the both of them. So we group the first term, cos of x minus cos of x, cos of h, group them like this, plus sine of x, sine of h. Now we can separate this denominator, h cos of x plus h, And then we do the same thing here, h cos of x plus h, as h now is approaching 0. So if we factor out this cos of x, but remember we can take the limit of this term and this term so that we can bring in some of these properties. So we take the limit of this, and then we also factor out cos of x. So you'll be left with 1 minus cos of h, all over h cos of x plus h. As h approaches 0, I do the same on this side. Take the limit of sine of x, sine of h, all over h cos of x plus h. And then you have f prime of x now to be equal to the limit. So at this point, since we want to bring in these properties to make this thing a bit easy or much easier for us, we can rewrite these expressions in either of these terms. So look at the first one. Cos of x and cos of x can go out, right? Now you have 1 minus cos of h. 1 minus cos of h divided by h. So we got h here, right? Divided by h. So what we can do now, we can separate this h times this cos of x plus h. Cos of x plus h. We separated them, right? H is approaching 0. Plus also the limit of sine of h all over this h, as h is approaching 0, times the rest of them. Now we can just push them on the side, just drag them one side. So we have cos of x plus h. So this one is just 1. The limit of sine of h over h is 1. The limit of this one is 0. So it means this whole thing will go to 0. So you have, this is 1. Now you have sine of x all over cos of x times cos of x plus 0. H now is 0. So it just be cos of x, right? So you have sine of x all over cos of x times 1 all over cos of x. So sine over cos is tangent of x, and then 1 all over cos is secant of x. So this guy is just equal to, so the derivative of secant is equal to secant of x tangent of x. That is the derivative of secant. So thanks so much for watching. See you next video.